Welcome back to my channel. So today we are going to discuss about one more interesting and important topic in system Verilog, which is arrays. Okay, so in the previous session we have already discussed about the strings. Okay, if you didn't check it out, I'll link that in the description box. You can go check it out. Okay, and also if you are new to this channel, consider subscribing to this channel and hit on the notification bell also, so that as soon as I upload the video, you will be getting the notification. Also follow me on all my social media handles. Right? So let us not waste any more time and dive into today's topic, that is arrays. Okay, so as I told you, arrays is very important in system Verilog. Why? Because here what does an array mean? It is nothing but a group of variables which is having the same data type. That means, for example, if I am giving like int arr of some 5. Okay, now what does this mean? That means this array is having some 5 memory locations. Okay, so 5 memory locations, and all these 5 memory locations are of int data type. So that is what the meaning is. That means all the memory locations, all the things that it can hold, this array can hold, all belong to the int data type. So that means it is having the same data type. Okay, so basically, as we already know, in system Verilog, we are going to design very complex circuits. So while we are taking those complex circuits, we need many memory locations in order to save something or in order to design something also. So that is why whatever we are going to declare, mostly we will be declaring it arrays itself. Okay, and also in system Verilog, okay, apart from Verilog, like in Verilog we have already seen arrays, but along with those arrays, we are having many more advanced versions in system Verilog. Okay, in the upcoming sessions, we will be seeing all these array concepts. But remember one thing, arrays is very important. Okay, these are just the basics which you need to remember. Like when you are writing the code or else something, these are some of the basic things you need to remember. Okay, so that is what array means. So basically, as I already told you, we have already learned arrays in Verilog. Okay, now, okay, so let us see what is new in system Verilog before diving into what is each array means. Okay, so basically arrays in system Verilog are categorized into two types. Okay, one is static array, another is dynamic array. Okay, and in just like in Verilog, system Verilog also can have like single dimensional array or multi-dimensional like 2D or 3D, anything like multi-dimensional arrays also the system Verilog supports. Okay, so arrays are categorized into two types like static array and dynamic array. Again, in this dynamic array we are having lot more kinds like associative arrays, okay, queues. So all these also come under this dynamic arrays. Okay, we'll see all of these arrays in the upcoming sessions, don't worry about it. So basically, when it comes to arrays, it is categorized into static and dynamic arrays. Okay, so whatever this array is, like either it is static array or dynamic array basically. So what does the array do? As I already told you, it is for example, if you are writing like array of 5, then it is creating or declaring some memory locations, right? Is it or not? In order to store the values in that memory locations, or when you are assigning something, all the values will be assigned to these memory locations, is it or not? So basically, when it comes to the allocation of this memory locations, again in array you are having two kinds of memory allocations. Okay, one is packed array. Okay, another one is unpacked array. So basically, packed and unpacked array is nothing but how the memory allocations are being allocated. That means either they are allocated in a continuous format or in a non-continuous format. Okay, basically, packed and unpacked array means whether the memory is allocated continuously or non-continuously. That is the thing. Did you get my point? So I'll just repeat it one more time. Arrays are in system Verilog, arrays can be either single dimensional or multi-dimensional, and arrays is categorized into two types like static and dynamic. Again, in dynamic you are having many more kinds like associatives and queues, right? So based on the allocation of the memories, arrays are again divided into packed arrays and unpacked arrays. Okay, so both static and dynamic arrays can be packed and unpacked. Okay, so basically this packing and unpacking, this will be represented by how we are representing the array. Don't worry about it, we'll be seeing in the forward sessions, right? So clear. So this is about what is static and what is dynamic array. Now let us see what is the meaning of this static and dynamic. Okay, so basically, for example, if you are giving like array of some 3 down to 0, what does this mean? This means this array is having 4 memory allocations. Is it or not? Yes. So basically, when you are when you are mentioning a static array, then that means this, as soon as the compile at the time of compilation only, all the memory locations are being created. Got my point? In case of static array. Okay, did you get it? So what happens now? Let us see what is the difference between compilation time and simulation time. Okay, if you all know about what is the difference between compilation time and simulation time, you can skip this part. But if you are not, if you are new and if you have confusion between what is compilation time and simulation time, so basically compilation time is nothing but when you are compiling. Okay, when the system is being compiled, like when your code is being compiled, okay, it will be checking all the syntax errors. Okay, got my point? So whenever the code is run, first it will be checking all the syntax errors. If they are having any syntax or semantic errors, then it will be checking those errors. That is called as compilation time. So after checking all the syntax and semantic errors, then the simulation takes place. So simulation is nothing but whatever code that you have written in order to design a circuit, or for your design, what is the code that you have written, that will be executed, and that is called the simulation time. Okay, so basically this, when it comes to static array, okay, the memory is allocated at this compilation time itself. And once the memory is allocated in the static array, from the name itself you can say that it is static in nature. That means you can't again change it. Got my point? That is the main thing in static arrays. Okay, that means once you have created the memory locations, then it can be changed. Okay, so and also this memory allocation is done during the compilation time itself. That is about this static arrays. When it comes to dynamic arrays, it is entirely opposite to that. That means here the memory allocations are created during the simulation time, but not during the compilation time. And also, even though we have created the memory locations, we have the possibility to change the values. Like we have the possibility to either delete the memory locations or to add some memory locations. If we, based on the code, if we need to store some more, if we need to assign some more values, we can add those memory locations, or we can delete these memory locations. That means these are some flexible options when it comes to dynamic arrays. But in case of static arrays, all these are not possible. Clear? So this is the main difference between static and dynamic arrays. So what happens? So why this is a major disadvantage in static arrays? So why are we calling it as the major disadvantage? Why? Because as I already told you, we are, as soon as we are declaring the array, then during the compilation time the memory locations are created. Okay, for example, if you are creating an array like array of 100, okay, that means what happens during the compilation time only, since this is the static array, so all the 100 memory locations are created. Now what happens? Okay, since it doesn't have any chance to delete these memory locations, for example, out of these 100 memory locations, you are using only some 20 to 30 memory locations. Then what about the remaining memory locations? Even though you are not using those 70 memory locations, they are being created. Okay, so that means there is a lot of memory wastage in it. Is it or not? So, in order to avoid all these things, we have opted for dynamic arrays in system Verilog. Clear? So, this is the major disadvantage between static and dynamic arrays. Got my point? Yes, see, in system Verilog, we can write arrays which have either fixed number of elements or variable number of elements. That is what that means. Either we can fix those values to some certain size, or if we don't want that particular size, we can either opt for increasing or decreasing the size of the array in system Verilog by using dynamic arrays concept. Okay, so this fixed size arrays are also known as static arrays. Okay, that is what, either we'll call it as a static or fixed size, both is same. Okay, just like in the previous things we have in Verilog also we have discussed about functions. Okay, in functions also we have discussed like what is the difference between dynamic function and static function. So static is nothing but fixed size, either fixed size or static is same. Clear? Yes. So this is about fixed size arrays. So in Verilog, as I already told you, we have seen that only static arrays can be created. Okay, so that is the main thing in Verilog. In Verilog, we can only create static arrays. There is no option for dynamic arrays. Dynamic arrays was only introduced in system Verilog, not in Verilog. Okay, so what is the major disadvantage? That is what I told you. The size of the arrays once defined can't be changed. So why is if we can't change it, then if there, for example, in some situations, if we don't use that entire memory, there may be wastage of that memory space. Is it or not? So that is why we will be using this dynamic arrays in system Verilog. Clear? So again, as I told you, in this dynamic arrays we have already having lot many kinds like associative arrays and queues. Clear? So this is about arrays. Hope you are clear about this arrays. Okay, if you are having any doubt, you can ping me in the comment box. Okay, so these are the types of arrays. We already discussed this. So fixed size means static array. So either fixed size array or dynamic array, both can be either single dimensional or multi-dimensional. Okay, and packed and unpacked. So based on the memory locations you are allocating and how you are representing the array, again it is categorized into packed and unpacked arrays. Clear? Okay, right? So let us see what is fixed size array, how we are going to declare and assign values to this fixed size array. So as I already told you, in static array the size of the array is known in the compilation time itself. That means during compilation only, when you are declaring the array and when it is compiling, okay, during that time only the size of the array is being created. That means the memory locations are being allocated to that particular array during the compilation time itself. So this makes it possible for the simulator to ensure that a continuous chunk of memories is allocated for the array. Okay, we will discuss this later. Like when we are discussing about packed and unpacked array, we will be discussing this point. Okay. Also, as the size is defined in the compile time, it is not possible to change the array later during runtime. This is the important point. We can do this for dynamic array. Like even though we have given the size, we can change it in the runtime in dynamic array. But in static array, there is no possibility to do that. Okay. Thus, these arrays are known as static arrays. That is why static. That means there is no flexibility for them. Okay, by default the array will be initialized with value 0. That means if you are not assigning any value to that, so by default the values of that particular arrays will be zeros. Okay, now let us see how we are going to declare the array and how we are going to assign values to that array. Okay, for example, first we are taking a single dimensional array, right? So this is how you will be declaring arrays. Like these are two types, either you can declare 6, that is called compact declaration, okay, or 5 down to 0, which is called as verbose declaration. You can do anything, both of this. So when you are declaring it, what happens? So 6 means total 6 memory locations will be allocated. Okay, whatever values you are going to assign in this memory locations, they will be given to this memory locations based on the indexes. Okay, so these are the indexes. Indexes is nothing but just a numbering or anything for that memory locations. Clear? Yes, when it comes to assignment, it can be done in either of these ways. Like you can either assign it like this: int array of 6. Okay, you will be assigning the values on in this way, like tick. Okay, within flower basis, you will assigning all the values. Or if you want to assign it individually, you can do this in this way, like int array of 6 and array of 0, array of 1. You will be giving it individually. Now what happens? Array of 0. So what is array of 0? So based this 0 is nothing but index. Okay, so based on the index array of 0, what you want to assign? You will be assigning 5, 6, 7, 8, 9, 10. So in this way the values will be assigned. Okay, clear? So this is the small example for the single dimensional array. Like module, for each example, okay, I am taking int array of 5. That means 5 memory locations will be created, and immediately I am assigning the values by using this tick format. Okay, instead of opting in this manner like individually, I have giving all the values within the same line itself. Like I am taking 5 values, since 5 locations, so 5 values. Okay, now I want to display all these values. So in order to display the values, you can use this like initial, begin, for each. Okay, so basically for each is a loop just like for. Okay, you have already seen for loop, while loops in Verilog itself. Okay, the same working will be there in system Verilog also. Okay, in for loop, if you see, you will be having like some initialization and condition and then increment. So all these things will be there. Okay, so instead of doing all these things, okay, you can do this, but instead of doing all these things, there is much more advanced option in system Verilog, which is for each. Mostly you will be using this for each loop only for arrays. Okay, so for each array of 5. Now what happens? Until the size of the array is completed, this loop it will be looping. This for each loop will be running itself. After the size of the array is completed, then it will be coming out of the loop. So array of I. So what is the size of array? 5. So it will be looping for 5 times and then displaying all the values. Okay, so in this way it will be displayed. Clear? So this is the single dimensional array. If it is a multi-dimensional array, okay, so basically when you go to for multi-dimensional array, the first one will be considered as rows and the second is columns. So basically 6 rows. If you see here, okay, 6 rows and 2 columns. Okay, like 0, 1. Clear? So basically this is how you will be declaring the multidimensional. Okay, you will be declaring and you will be assigning the values in this way. Again same, since you are having both rows and columns, so 2 values at a time you will be having all the values. Clear? So for this also the same example, if you see here, module for each, okay, 6 int array of 6 of 2, 6 2, that means 6 rows, 2 columns. Okay, so all this will be initialized within. If you see here, see, individually I'm assigning, because yeah, it is a two-dimensional array. That means you should assign the values for rows as well as columns. Okay, when you are doing this, you should individually. You see the assignment here. This is the main important thing. Okay, when you are writing some array for single dimensional, it is no problem. But when you are writing for two-dimensional things, you have to check all these things. Like this is for all the entire thing, and again in the entire thing for one row, for single row and single column, like 0 0 0 1. So this is how 0 0 for this, again it is one block, 0 1 one another block, 1 0 1 1, like this. Okay, so basically this is how the thing takes place here. Okay, again in order to display, since it is two dimensional, I am taking two values like I and j. Okay, for each of I and j begin array, again I am displaying like two values. So array of 0 1 0 0. So what is there in every value, I want to display that. So in order to do that, this is the way. Okay, dollar display, right? And then this is how the multi-dimensional, basically a two-dimensional. When you are going for three-dimensional, this is how the program will be. Again, I don't want to explain everything because everything is same here. Like if you see, for 3 dimensions you're having 3 values. Okay, clear? Okay, you just check out this, you just pause this video and check out the program. And still if you are having any doubt, you can comment me in the comment box. I'll definitely reply you as soon as possible. Yes, and then coming to the main topic, which everyone will be mostly confused. Okay, even today, even though when you are again repeating for system verilogs, again checking for system verilogs, then also, even though you are some experienced person, or even though you are not a beginner also, mostly many of them will be confused in this topic, which is packed and unpacked arrays. Okay, so now let us today discuss about what this packed and unpacked arrays means. Okay, so basically, right, packed from the name itself, it is saying that packed means everything is in a packed format. Okay, unpacked means it is not in a packed format. We can talk it like that. Okay, so what does this packed and unpacked array means? Okay, so basically, in simple words, when the memory locations are in continuous format, okay, then we call it as a packed array. And when the memory locations are not continuous, then we call it as a unpacked array. Simple thing. Okay, so basically when memory locations are continuous, it is packed array. When memory locations are not continuous, it is unpacked array. So now comes the point. So how we are going to know whether it is packed array or unpacked array, or at which point of time, like for which array we will be using this packed arrays and for which array it will be unpacked arrays. Okay, this is the main important thing, right? So as we first, let us see how the memory locations in packed array will be. So basically let us take this example here. See, register 11 down to 0 array. If you see this representation, you may have doubt. Okay, so basically in Verilog we have talked about the difference between vector and array. Okay, there we have clearly mentioned that, okay, if anything, if the notation, like if the representation is, if the width is mentioned before the variable, then it is called as vector representation. If the width is represented after the variable, then it is array notation. Okay, so you can go for my short video also, where I have explained about what is the difference between vector and array. So basically, that from that means, if the width is mentioned before the variable, that is called as vector representation. Okay, nothing but you are mentioning the magnitude of the variable you are taking. So this magnitude is actually called as a packet dimension. That's it. Okay, so basically what is happening here means, when you are mentioning the variable dimensions before the variable, then that is called vector representation, or else we will call it as a packet dimension also. So in this packet dimension, what happens means, so as if you see here 11 down to 0, that means 12 memory locations. So as soon as this representation is taken, all the 12 memory locations are allocated continuously. Okay, that means all the memory locations are allocated in a same row. Clear? So this is the packed array. Okay, for example, if you see this particular example, see, 2 down to 0, 3 down to 0 array. So this is the packed array. Why it is packed array? Every representation, every width is given before the array, not after the array. We are going to give it after the array name or array representation, then that is unpacked array. If it is given before the array name, then that is packed array. Okay, I'll also tell in the last like at the end of this video how to differentiate between, I'll give you a trick on how to differentiate between packed array and unpacked array, like how I used to remember when I used to study or when I used to go for interviews and all. Okay, I'll give that particular tip to you, so don't skip this video and watch till the end in order to know that tip. Clear? Yes. So that is bit 2 down to 0, 3 down to 0 array. Now this is packed array. So when this is packed array, as I already told you, when it is a packed array, all the memory locations will be continuous. So now if you see the 3 down to, this is my first array. Okay, this is my second array. This is my third array. Now each of my array can hold 4 bits. Okay, that means here 0 0 1 0 1 0 1 1 1 1 1 0 1 1. Okay, that means this is my values. That means, for example, I want to store 246. Then what happens? The 6 will be stored in this particular 4 locations, 4 will be stored in this memory locations, 2 will be stored in this particular memory location. Okay, this is packed array. So whenever you are representing a packed array, it will be in this format. For example, you are representing like 1 down to 0, 3 down to 0, ARR. Now what happens here? It will be having two memory locations. Okay, and each location can store 4 bits. Okay, so this is how the thing is done. Clear? So this is about the packed array. Okay, now let us see the example here so that you will be much more clear. So if you see module array example, and this is my array bit 2 down to 0, 3 down to 0 array. Now what does this mean? That means it is having 3 memory locations. Okay, 3 memory locations like 0, 1, 2. Why? Because 3 memory locations where each memory can store 4 bits. That means within this memory again it can store 4 bits. Clear? Yes. So now what happens in the first memory location? That means this is 0, 1, 2. In the first memory location, I want to store the value 2. If you see the size here from this also, you can check out like 4 tick. That means everything can store 4. So what is the value I want to store? I want to store 2. That means 0, 0, 1, 0, 4. That means 0, 1, 0, 0, 6, 0, 1, 1, 0. In this way, the values will be stored. Okay, after assigning the values to this particular array, in order to display those values, again you will be using for each array of I. Okay, dollar display. Whatever I want to store, I will be storing. I'll be representing that. Okay, by using the dollar display, I will be displaying all the values and then end module. Okay, so this is about packed array. That means packed array means if you see in this, all the memory locations are continuous. Is it or not? That means 1 is stored and then again after that means here 2 is stored, immediately 4 is stored, immediately 6 is stored. That means everything is in a continuous format. But this won't happen in unpacked arrays. Why? Okay, so that is why if you see in the starting, okay, I told I'll be discussing it later. Like in static array, the memory location is continuous. Why? Because we are giving, that makes it possible for why we are the memory is creating during the compilation time itself. That means at the starting only you will be getting the okay, let me give you a small example for this. So, for example, if you are booking a ticket for for a bus where the entire bus seats are empty, so now what happens if you are taking some 10 to 15 tickets, and if you want all the continuous tickets, you can have it because since the bus is empty, so all the 15 tickets for you will be given in continuous manner. But when you are doing it when bus or train is half full, then is there any possibility that you will get all the continuous tickets? No, right? Similarly, during the compilation time only in static arrays, we are giving the memory allocations. So that is why there is a full possibility for having continuous chunk of memory. Okay, but for dynamic array, as I already told you, this memory is allocated during the simulation time. That means simulation means for compilation everything will be done. Okay, and then after simulation, that means just like now the bus or train is semi filled. Okay, now there may be or may not be having the possibility of having the continuous chunk of memory. Okay, got my point? So this is the difference between packed and unpacked array. So what happens in unpacked array is basically just like this, as I told you, the memory allocation is not continuous. Okay, for example, if you have taken the same example like int array 2 down to 0, 3 down to 0. Now if you see the allocation, there is the difference here. How can you tell the difference between packed array and unpacked array? Okay, if the array allocation, if the memory allocation is given before the array, then it is called packed array. Okay, if the memory allocations, if the declaration is given after the array name, then it is unpacked. That's it. Okay, now this is unpacked. So since this is unpacked, the memory locations may or may not be continuous. Just like in the before example, you may get the continuousness or you may not get the continuousness. Okay, just like that it is. See, in this way the locations, if you, even though you are taking 2 down to 0, 3 down to 0, each can hold 4 bits, but this is not continuous. If you see in the before packed array, all the things are in a continuous manner. But here it may or may not be, because if all first 4 bits are stored in first location, now again it is going for another place where it is empty and it is storing the remaining values, another place where it is empty and it is storing the remaining value. So in this way the memory is not continuous in unpacked array. That is the main difference between packed and unpacked array. Got my point? Yes. So when you are writing the same example for this, here if you see, when you are creating the memory locations, 1 2 3 4 is stored in one place, and 5 6 7 8 may be stored in another place, and 9 10 11 12 will be stored in another, like in another memory locations. Okay, in this way the memory will be not continuous but in non continuous manner. Clear? So as I told you, I'll be telling the last tip for you, which is the difference, in order to know the difference between packed and unpacked array. So for this, okay, just remember a name like Paul. Okay, for this, let us consider this A as array. Okay, if you are mentioning the width before this array, then it is a packed array. P for packed. If you are mentioning the width after the array, then it is unpacked. U for unpacked. Okay, so this is just a tip I used to remember. If you like it, you can remember this tip as well. Okay, so I'll be giving much more tips for the in further sessions, like for the remaining topics also. Okay, for all this what you have to do, you have to subscribe to my channel and hit on the notification bell also. Also, I'll be uploading all these ppts in my telegram channel, so do join in the telegram channel also. I have given that handle in my YouTube channel. You can go check it out and join this.